Welcome to the AI Factory podcast. You know, we all use AI, right? For everything from a quick search to getting help writing an email. But have you ever stopped to think about what it physically costs to get that answer from the cloud? Well, in this explainer, we're going to pull back the curtain on AI's hidden environmental price tag. So let's kick things off with something we literally do all the time, a search. But here's the thing, an AI search is a completely different beast than a traditional one. A normal search is like looking something up in a giant encyclopedia. It just finds what's already there. But an AI query, it creates something brand new. And that act of creation, well, it takes a whole lot more juice. We're talking nearly 10 times more power for just one single answer. It's a pretty big difference.
Okay, so that energy jump is huge, but believe it or not, that's only half the story. It turns out AI isn't just power hungry, it's also incredibly thirsty. Think about it. All those powerful servers generating our answers are like tiny little ovens, and they get hot. How do you cool them down? With fresh water. And it's kind of wild when you realize that just a short back and forth with an AI, maybe 20 to 50 prompts, can use up an entire bottle of water. And most of that water just evaporates, gone from the local system.
Now, that one bottle of water might not sound like a lot, but what happens when you scale that up for millions of users asking billions of questions? Well, the numbers get absolutely staggering. The projection for just the US by 2028 is 720 billion gallons of water per year, just for cooling AI servers. And you have to remember, this water is often being pulled from places that are already struggling with shortages. It's a massive amount. So what does 720 billion gallons even look like? To put that into perspective, imagine over 1 million Olympic-sized swimming pools. That's how much water we're talking about, every single year. All of this really brings us to a pretty fundamental question, doesn't it? Why? Why is AI so thirsty and so power-hungry? What is it about this new kind of computing that demands so much from our planet? Okay, so to get to the bottom of that, we really need to look at the core of how AI consumes resources. Let's break down the environmental footprint, looking at what happens both inside the data center and outside of it. You see, AI's footprint isn't really one single thing. It's more like a chain reaction with 3 big links. The first one is that on-site cooling. That's the direct water use we were just talking about, right? The second is the off-site electricity generation. I mean, all those processors need a ton of power, and that power has to come from somewhere, often from the grid. And then there's the third piece, something people don't always think about, the embodied impact of the hardware itself. That's all the resources, the mining, the manufacturing, just to build these specialized chips in the first place. And all this consumption happens across 2 really distinct phases in an AI model's life. First, you've got the training. This is a massive, one-time-only process. It's incredibly energy-intensive, where the model just chews through vast amounts of data to learn. But, and this is the key part, the bigger piece of the pie over the long run is what's called inference. That's the ongoing, daily grind of actually answering our queries. Millions and millions of them every single day. So even though training is this huge, intense burst of energy, it's actually the daily use by you, me, and millions of other people, that inference phase, that ends up using most of the energy over the model's lifetime. So what does all this actually mean for the real world? What are the consequences? Well, this huge demand for resources, it's not happening in some abstract vacuum. It has real, tangible effects on local communities and even on global climate goals. And this quote from activists in Spain, wow, it just hits you, right? Your cloud is drying my river. It's such a powerful reminder that the cloud isn't just up there somewhere. It's a physical building with a physical address having a very real impact on the local environment. And this isn't just about emotional slogans. The actual data shows a pretty troubling trend, especially when you look at the companies at the forefront of AI. They have these really ambitious climate pledges, right? Carbon negative, water positive. But the reality is, the sheer demand from AI is pushing their emissions and their water use up, not down. It's creating this massive gap between their goals and what's actually happening on the ground. And that trend at the corporate level has very real on-the-ground consequences. To feed AI's insatiable appetite for energy, we're seeing utilities actually delay the retirement of old coal plants. They're building brand new natural gas plants specifically for data centers. In places like Arizona and Oregon, you've got farmers now competing directly with data centers for the same scarce water. And for many of us, it might even be hitting our wallets as electricity rates go up to pay for expanding the grid.
But, okay, let's take a step back and get some perspective here. How does AI's water use stack up against other big industries? And this comparison is pretty eye-opening. While the water for AI is significant and growing fast, it's still dwarfed by something like agriculture. I mean, the amount of water it takes to produce a single hamburger, we're talking thousands of gallons. It's a whole different scale. So what this tells us is that while AI's footprint is a serious, fast-growing issue, it's really part of a much bigger global conversation we need to have about how we manage all our resources. And this leads us to the really big question, the one we always seem to come back to with technology. Can it solve the very problems it creates? And that challenge, the environmental cost of AI, has actually sparked a whole new wave of innovation. People are really focused on finding a more sustainable way forward. It's being called green AI, and it's basically a movement that says, hey, maybe accuracy and performance aren't the only things that matter. Maybe energy efficiency and environmental impact should be right up there as key metrics too.
And look, this isn't just some abstract theory. There are concrete paths people are taking to make this happen. We're talking about designing more efficient hardware, specialized chips that can do more with way less energy. We're talking about smarter algorithms, making models smaller and less computationally hungry. It's also about being smart about where you build data centers, putting them where clean energy is abundant, and finally, completely rethinking the cooling problem.
And that last point, the cooling, is one of the most exciting areas of innovation right now. Instead of those massive water-guzzling evaporative towers, some of the newest data centers are using something called liquid immersion cooling. They are literally dunking the servers directly into a special non-conductive fluid. It's way more efficient at pulling away heat and uses a tiny fraction of the water. It's a total game changer. When you see advancements like that, it starts to reframe the whole problem. It suggests that maybe this isn't a simple choice between progress and the planet. And that brings us to the core question we want to leave you with. Do we have to choose between innovation and preservation, or is it possible that the need for preservation can actually become the biggest driver of innovation? Answering that question is really the defining challenge of our technological era. Now, if you want to dive deeper into how these vast AI systems are built and managed, we really encourage you to check out the book AI Factory: Architecting Global Supremacy. We put a link for you in the description below. Thank you so much for joining us.